Hello everyone, myself Ramesh Masuna, faculty of ACE Engineering Academy. Welcome to ACE Engineering Academy and ACE Online. Today we are going to discuss about the compiler design PYQs in ISRO. And ISRO recruiting engineering graduates in computer science stream as a scientist position, and there are total number of 44 positions. In this regard, ACE Engineering Academy is conducting a ISRO PYQ series. In that part, here in the today's session, I am going to take compiler design PYQs. Okay, welcome to the session to all of you. And when it comes to the compiler design, there are certain topics are there in the syllabus. Those topics are called lexical analysis, parsing, syntax directed translation, intermediate code generation, code optimization and code generation. These are the 6 phases of compiler, and each of the phase is one chapter, and these are the contents of the syllabus in compiler design for ISRO. But when it comes to the compiler design for ISRO, you look at the weightage analysis. I have analyzed about the 2007 to 2023 recent paper which happened in 2024 January. So analyzed all the questions, all the papers, and here I found on introduction and lexical analysis chapter there are totally 12 questions came, and these questions are 2007 to 2023 papers. And in a parsing, that is a very good chapter and most weighted topic. So far 18 questions came, and code optimization 8 questions came. So means totally of 38 questions I found it. Okay, this is according to my knowledge. Okay, according to my knowledge, I have observed all the papers. I have seen that there are totally 38 questions from 2007 to 2023. Okay, now here I have told you there are 6 topics in the chapter. In that 6 topics, first topic, second topic and optimization topic means lexical analysis, syntax analysis and code optimization. And so far no questions are asked on syntax directed translation, intermediate code generation and code generation. Those are the topics from where no questions are there, and these are the topics from where questions are given. And very first I'll start the session. Before I start PYQs, I'll start the session with what is compiler, because just I want to start the session with what is compiler and what is the output of a compiler. As generally people, most of you say compiler will translate high level language to machine language, but I say compiler is not always translates high level language to machine language. It might generate some different forms of outputs. That outputs could be either assembly language program or machine code, could be relocatable machine code or absolute machine code. That's why we can say compiler is a language translator. We can say compiler is a language translator that can read a program in one language, we call it as a source language, and that translates it into equivalent program in another language called target language, means source to target. Now you can see compiler takes input a source program and translates that source program into target program. And what are the target programs? Target program could be assembly language program or relocatable machine code or absolute machine code. These are the different forms of machine code. And most of the compiler designers, they design a compiler such that its output should be assembly language program. Its output should be assembly language program. Why? Because before the development of compilers, assemblers were already developed. So what assembler do? Translates assembly language program into relocatable machine code, and this relocatable machine code loaded into main memory for execution so that it becomes absolute machine code. So this is a absolute machine code that is executed by the CPU. But most of the compilers designers, they develop assembly language program as an output. So means what output that you want as an output of a compiler, when you are designing a compiler, you should decide it. That's why you don't conclude that as a machine code always. It is your choice that output of compiler is assembly language program or relocatable machine code or absolute machine code. Let us say an example, Java compiler. What is the output of Java compiler? Is it a machine code? No. The output of Java compiler is a byte code. Means the developers of Java compilers, they did in such a way that the source program should be converted into byte code. That is a choice of a designer. It is not machine code always. That's what I'm telling you. Don't say machine code always. Okay, right. This is about just a formal definition of a compiler. Now, in the PYQ series, I'm going to continue my session with the different PYQ questions. As I have shown you, there are something around 38 PYQs are there. Those PYQs we are going to discuss. And before I discuss those PYQs, I want to give in brief from where questions are asked and what are the possibilities from where questions are going to be asked. Okay. Previously in ISRO paper, questions were asked on finding number of tokens. This is one topic where questions are asked, finding number of tokens. This is one topic. Okay. And apart from that, we also have some questions on parsing and moreover theoretical questions, like theory questions on phases of compiler, theory questions on phase of compiler, like which phase will read the program character by character, we call lexical analysis phase, which phase takes syntax tree as input, like this kind of questions, which phase will check will perform type checking, semantic analysis phase. This kind of questions were asked. Theory questions on phases of compiler. So these kind of theory questions are multiple there, and some match the following kind of questions also given on the phases of compiler. Match the following kind of questions. Actually, this match the following kind of questions asked in the previous gate questions, and the previous gate type of questions are asking same thing in ISRO papers. As when I have taken ISRO series for DBMS, also I have shown you some certain examples where the question is of previous gate question, and that is in the next years, that is a previous ISRO questions, same questions, even data is also not changed, and so that it is one expected topic. And most of the questions I have seen on introductory part on phases of compilers, and some questions were asked on parsing. In parsing, the questions were asked on the precedence and associativity of the operators, precedence and associativity of the operators. And there are certain questions I have seen that questions on number of parse trees for a given grammar. For the input, it is asked number of parse trees, and I have seen some questions on left recursion and left recursion elimination, right? But we expect some questions on predictive parse table. On predictive parse table, questions were not there in the previous ISRO paper, but predictive parse table questions were asked in the gate examination. So gate kind of questions you can expect in the ISRO papers. So predictive parse table kind of questions, we can say it is expected questions. So whichever is expected topics, I am just marking it. And the questions are possible on viable prefixes. What are the viable prefixes? The prefixes of the right sentential form that can appear on the stack of a shift reduce parser, or viable prefixes. This is also expected topic in ISRO paper. And then some questions are based on type of LR grammars. What is the type of LR grammars? Means you will be given some grammar and asked to find the grammar is of LR of 0 or SLR of 1 or relay LR of 1 or CLR of 1. Some options like LR of 0 but not SLR of 1, SLR of 1 but not LR of 0. These kind of options might be given, and this is also one of the expected topic, okay, on LR. And one question I have seen on the operator grammar, like which of the following is operator grammar. What is an operator grammar? Operator grammar is a null free grammar, and it has a property that no two non-terminals are adjacent. That is a question I have seen. Then 11th one. Next is questions on syntax directed translation. But when you see the previous gate questions, they have given syntax directed definition, some input, and asked to find output according to the translation for the input sentence given. But that is bit lengthy question, but instead of giving some bit lengthy question, means that those are 2 marks kind of questions in the gate examination. But when it comes to the ISRO, they are asking 1 mark questions. When it 1 marks questions, instead of giving the bigger SDD and bigger input and asking to find the output, you may expect some smaller questions like SDD with small certain 3 to 4 rules with some input and ask to find the output for the input based on the translation. Means instead of giving it as a lengthy question, you may expect a smaller questions. Questions on SDD, these are the expected, and questions on types of SDD. What are the types of SDD? S attributed and L attributed, syntax directed definition. Types of SDD. What is that? S attributed definitions or L attributed definition. The previous gate, recently on also in 2025, one question asked on types of SDD, S attributed and L attributed, and those kind of questions, because recently in 2025 asked now. So the similar kind of questions you can expect in next ISRO paper also. Okay. Then questions on translation scheme. These are also expected because questions are not asked on translation scheme. You may expect questions on translation scheme. And next, some of the questions on intermediate code generation, like 3 address code implementations. What are the 3 address code implementations? Quadruples, triples, and indirect triples. Recently in GATE 2024, one question asked on 3 address code implementation, quadruple implementation, quadruples or triples implementation is given. Similar kind of question you can expect in the upcoming GATE examination, because what I observed personally is whenever a different type of question came in the GATE examination, the similar type of question it appeared in the next ISRO papers. So because recently questions asked on TAC implementation, triples representation, and types of SDD, these are the most expected. What I am expecting is you may expect this year on these 2 topics mandatorily. And then we have a questions on code optimization techniques, and questions were asked on optimization techniques also. Optimization techniques, like what is common sub expressions, what is a strength reduction, what is a copy propagation, variable propagation. These kind of techniques are there, like loop optimization, code motion optimization, induction variable eliminations. On these optimization techniques, questions were already asked in the previous GATE. So you may expect some different type of questions, like you may be given some code snippet and asked to find what optimization can be done on the particular code. That is an expected thing. But some questions are already asked on code optimization. And questions on code generation. Like if some 3 address code is given, they might ask you for generating the target program for the intermediate code, how many number of registers are needed without spillages, number of registers that are required. And these are the expected type of questions. Here I have shown you totally 16 topics I have written. Okay, 1 to 10 and 11 to 16. So totally 16 topics I have written. Just I will be moving aside for a bit moment, and you can see these 16 topics one at a time. If required, you can take a snapshot of it. That could be for your later references, where I have marked some of the ticks, right? And those are the topics from where questions were not asked, but it is most importantly possible to be asked. Okay, I hope you have taken a screenshot of it if possible. Okay, and that could be for your easy reference or future references. Okay, whenever you are preparing, you can look into those topics. Fine, I'll be coming to the picture again. Okay, now these are the topics to be focused for ISRO 2025 exam and from compiler design subject. Now, because it is a PYQ series, we'll go ahead with all PYQs to be discussed one by one. Okay, before I discuss these questions, I suggest you to look into these questions and if possible try to answer before I explain you. Okay, for each question I will wait for 1 minute so that it will be good even for me and for you also, like it looks like a sporting spirit for you. Okay, I'll be watching. Okay, here I'm facing an issue. Any answers? Okay. Any answers, dear students? Kondaka Pranav. Okay, number one, thank you. Atre Chaudhary, sir, can we make a symbol table using binary tree? Yeah. Atreya Chaudhary, you can, binary symbol table can be implemented using any of the data structures like binary tree, linked list, or something else. Okay. Uh, yeah, you're sure. You're correct. In 2025, it is asked. Lohita Reddy, good. Sudeep Rao, good. Okay, what you gave? D. So look at ISRO 2023 question. Which sequence below best describes the order in which the phases of compiler typically work? In which order? Syntax analysis, then lexical analysis. It is incorrect. Now, first lexical, then syntax analysis. Lexical analysis, syntax analysis, semantic analysis, code optimization, intermediate code generation. First intermediate code generation, then code optimization. Code optimization is done on the intermediate code, not on the source program. So B is incorrect. Syntax analysis, lexical analysis. First lexical analysis, so C is incorrect. Lexical, syntax, semantic, intermediate code generation, and code optimization. This is an order of phases. Okay, that is one question which is asked recently in 2023 ISRO paper. See, what I observed is ISRO paper questions are very easy when compared with the GATE paper questions, because mostly I have seen theoretical type of questions. And look at this is the same question asked in GATE 2003. Same question. It is a question asked in GATE 2003. Later it is same question. Data also not changed. Same question asked in ISRO 2015. Now what is the answer for this question? The number of tokens the following C statement is. The number of tokens the following C statement is. How many? You can go ahead with this. What is the token? A logical unit of a program. How many tokens in this program? Very good, Lohita. C. Yeah. 1 and it is 2 and everything that is there in the double quotes is considered as string constant 3 and comma 4, I 5, comma 6 and 7, I 8, close 9, semicolon 10. So how many tokens? Totally 10 tokens. Oh, Atreya Chaudhary, is it 13? No, Atreya. You can check. It is a 10 tokens. Okay. That is a ISRO 2015 question. Now, look at, by looking, I wondered that almost every question is like theoretical question only. No challenging type of questions like GATE exam questions. Fine. I think you can easily answer all CD questions. According to my knowledge, I can definitely say you can easily answer. Sudeep Rao, why 11? For the previous question, it is not 11, Sudeep Rao, it is only 10. Now, the output of lexical analyzer is, what is the output of lexical analyzer? Parse tree, intermediate code, machine code, stream of tokens. What is the output of lexical analyzer? Tokens. It outputs tokens, all the tokens. Look at this one. It is again a recent question, ISRO 2023 question. Consider the context-free grammar G below for arithmetic expressions. Some grammar is mentioned. E derives E plus E, E into E or ID. The question is which of the following statements is true? Okay, have a look. Just I want to check. Techminder, Surya C, Sudeep Rao D. what way it is asked? Just look into it and answer it. And participate in the discussion so that you can also uh, like have a feel that you are also participating in the discussion so that you can answer the question. Hmm? What is the answer? What type of grammar it is given? Is it ambiguous or unambiguous grammar? I can say it is ambiguous grammar. Why? It is both left recursive and right recursive. It is ambiguous grammar. If it is ambiguous grammar, it generates more than one input sentence for some input, more than one parse tree for some input sentence. Now, question is, which of the following statements is true? The string id plus id star id has no parse tree. But id plus id star id you can get using this grammar, na? But it said no parse tree, wrong. The string id plus id star id, Atre Chaudhary, I think C. Okay, you think C? Okay, Sudeep Rao C and Lohita ambiguous. Okay, fine. The string id plus id into id has only one parse string. Is it one parse tree? Just let me check it. But it is not one parse tree, definitely I can say. id plus id star id. E plus E once I can do. E tends to E into E. I can do it one more time. Because id plus id, so E should become id. This is E into E. And this E's are going to become IDs. And because this E into E plus E into E, right? So that it will be E and plus E, and this E should be ID. But what is said here? The string ID plus ID into ID has only one parse tree, but it is two parse trees, so option B is wrong. The option C, what it says is the string ID plus ID into ID has exactly two parse trees. Yes, here I found two parse trees, 1 and 2. These are the two parse trees, so we can say it is correct. The string ID plus ID into ID has more than two parse trees, but it is having exactly two parse trees, so that option D is wrong. So option C is the correct answer for the question. Okay, so simple. Instead of asking how many parse trees for that input, it is asked options like this. Sure. Go ahead with this question. This is again straightforward from GATE 2003 question. It is a GATE 2003 question, and that is asked in ISRO 2015. So most of the questions of GATE are given in the ISRO paper directly. I don't know why. Yeah, Atre Chaudhary, correct. You are right. Okay, look at this question. Given the following expression grammar, E derives, E star F, F plus E, F, F derives, F minus F, ID, which of the following is true? Lohita, very good. I am expecting remaining people also to answer. Which of the following is true? Star has higher precedence than plus, and we know that these two operators are defined with a starting non-terminal. Any operator that is defined with a starting non-terminal means star and plus are having lowest precedence, because in the evaluation of parse tree in the bottom to top, those operators are going to appear in the last place, so that it is going to be evaluated last. We can call least precedence. And because both the operators are defined with same E, we can say both operator, because defined with E, we can say star and plus are having equal precedence, right? And you can look at minus is defined with F, so that minus is having higher precedence. Now what option is star has higher precedence than plus, but star and plus is having equal precedence according to the grammar. So this is wrong. Minus having higher precedence than star, yes. Plus and minus having same precedence, no. What precedence is there for plus and minus? For plus and minus, plus is having least precedence, and plus has higher precedence, no, plus has lower precedence. So answer for this question is option B, right? So option B, very good. Sudeep Rao, Lohita, Atre Chaudhary, Pradeep, and Techminder Surya. Wow, nice. There is a good participation now. Okay. Look at again, this is also a direct question in GATE 2014. It is a GATE 2014 question, because over the years I taught many number of times now. I do remember even the years also. It is a GATE 2014 question, and it is a ISRO December 2020 paper. So, I have seen most of the GATE questions directly given in the ISRO paper. That's what I strongly recommend you solve all the previous GATE questions to ready for ISRO paper. Given the grammar, which of the following statements is wrong? Which of the following statements is wrong? Tell me. Grammar is not ambiguous. Whether is it ambiguous or not, we can't say right now. But is it ambiguous or not? How did you say? Because to verify ambiguity, we don't have any algorithm. So I'll keep this statement aside. Priority of plus over star is ensured. Priority of plus over star. What does it mean? Priority of plus over star means plus is having higher precedence than star. Look at the grammar is having a starting non-terminal s, and with s star is defined. So any operator defined with any operator defined with a starting non-terminal having the lowest precedence, then plus I can say highest precedence. But what is the meaning of this plus having higher precedence than star? Okay, priority of plus over star is ensured, correct now? Plus is having higher precedence. Okay, this is correct. Okay, this is I have not concluded because we don't have any algorithm to test for ambiguity. But it is said not ambiguous. Okay, ambiguous or not, I don't know. Just I'll check it later. Right to left evaluation of star and plus happens. Right to left evaluation of star and plus happens. If evaluation to be right to left, so it should be right associative. It should be right associative means the rightmost symbol in the RHS should be same as LHS. Here also you can look at rightmost symbol in the RHS same as LHS. Okay, this is also perfect. The question is which of the following statement is wrong? So grammar is not ambiguous. Actually, by looking this one, I can say it is right recursive grammar, and you can't expect more than one parse tree for any input generated by this grammar. So we can say this is not ambiguous grammar. This is also correct, but question is about wrong. All are correct statement. Nothing is wrong. So answer is none of the above. Okay. So actually in GATE 2014, the same question given, but options are slightly different. Options are slightly different. At least they can do this much of differences, but some of the questions are directly copied. Okay. Next, I found this question is a joke. Even you can look at a grammar is defined as grammar given. The question is the non-terminal alphabet of the grammar. The non-terminal alphabet of the grammar. What are the non-terminals? Capital letters are non-terminals. That's it now. A, B, C. What are the non-terminals? A, B, C, D, E are the non-terminals. That's it. Option A. Very good, Atreya. But nothing was there. I don't understand why these kind of silly questions are given. Which variable does not derive a terminal string in the grammar? Which variable does not derive a terminal string in the grammar? Sudeep Rao, correct. Atreya, good. Okay. Which variable does not derive a terminal string in the grammar? Look at A is deriving a terminal, B is deriving a terminal, and C, are you getting any terminal with C? No. And S is deriving a terminal, because S with A with A, small a possible, S with B with capital C is there. Okay, but capital C is not deriving any terminal, but S is at least deriving at least one terminal. The question is which variable does not derive a terminal string, which is not deriving any terminal string. C is not deriving any terminal string. So answer is option C. What happened? A is deriving a terminal, right? B is deriving a terminal. Okay, S is deriving A is A possible, B is deriving B possible, means with S you are getting terminals, with A you are getting terminals, with B you are getting terminals, but with C you are not getting terminals. That's why it is answer. Okay, very good, Atri. Right, you are correct. Right. Now, next question is in 2011 ISRO paper. Which of the following sentences can be generated by the following grammar? So, means which input sentence is derived by this grammar? So, how do you solve? Can you solve it? Can you solve it? Which of the following sentences can be generated by the following grammar? S tends to AS, BA, A tends to D, A tends to CA. I think this should be small c. Okay, just I am writing it again. C, small c, capital A, because we don't have a capital C. Okay, because we don't have a capital C. Okay, any answers for this question? So, how do you solve? Derive the input. First one you can check. S tends to BA, B derived. Using A you should get C. You can get CA again, and again with A you can get CA again. Second C also came. With A we have to have D, but one more D is left, that is not possible. So, option A wrong. Option B, with S I want to get A, so using AS this is possible. With S I want to have B, so that BA I can make it, so this B possible. With A I want to have B, with A if I have to have B with A, but A is not deriving B, so here it is also wrong. And go ahead with the third one. S is deriving AS because A wanted, A possible. With capital S I want to have B, so we go with the BA, so B correct. With A I want to have C, that is possible. C, A is an one of the option. With capital A you want to have A, have A, okay, that is not possible, right? A is not possible with capital A, so this is also wrong. And when it comes to the last option, S is deriving AS, A derived. To get B using S we can go with BA, so B derived. To get C we can go with CA, C derived. With A to derive D we can go with the D. Okay, this is possible. So, what is a string derived by this grammar? Option D. Right? Okay, good. Atreya, because we can only end at D. Yeah, it's okay, Atreya. That's fine for that question. Right? Lohita Reddy, you answered D. Very good. Fine. Chalo. Now look at this question. What is the number of steps required to derive the string? Okay, to derive the string, how many steps are required? That is a question. How many steps are required to derive this string? Just try it. I'll just move aside. You try it once. Right. Have you tried? Any answers? Oh, for tech minder. Is it D? Done it. Excellent, excellent. What is the number of steps required to derive the string? Look at, we should go with S tends to SS or open S close. We should go with open S close only first. Why? Because You can look at how many opens, 1, 2, 3 opens, and for this one it is a close, for this open it is a close, for this, okay. First what I do is I will match that opening with closes so that my work will become simpler. Now this open will have this close, this open will have this close, this open will have this close, this is open close, and this is total close. So to derive the string, I should start with s tends to open as close. There is a one step, okay. So that first open, last close is there. Next, s is going to have two substrings. So we can say open s close. S is deriving with ss, second step. And the second s should have open s close, and first s also should have open s close. So what I do is open s close, third one, so that this open close happen. And even when I make it this second s as open s close again, so I am going to get this open, this close, that is also over, right? And because this is over, then that s should be nullified. This is a fourth step. Open s close, open, that s is, I want to make it null. This is a fifth step. Anybody done? Oh, pretty confusing, Atreya. That's what I am telling you. Be cautious in answering it. Fine, s tends to epsilon is there. Then again with s, we have to go with open, that s is to be ss again. This s is to be ss again. It is a sixth step. Why ss again? Because two opens closes are there. Only that is left. Open, that s is open s close, s, this is the seventh step. And next, that s is going to make it null, eighth step. This s is open s close, ninth step, and that s is to become epsilon now. This is the 10th step. So how many steps are there? Anybody done? How many steps have came? 10 steps. What is the number of steps required to derive the string? This is a string. To derive this, we have 10 steps. That is a question. Okay, I think it is clear for you. Done. Next, which one of the following is a top-down parser? Questions on top-down parsers. Okay, just answer it, and before that, if you have any doubt, just look into it because somebody said, sir, it is pretty confusing. Just I'm just moving aside. You can check with is it okay, or else any confusion still. Okay, little confusion at step 9. Lohita ready? Okay, now is it clarified, Lohita? Are you okay with this? Atreya Chaudhary, are you okay now? Atreya. Done. This, again I am coming to the picture. Could you please reply? Lohita, are you okay? Atreya, are you okay? Okay, Lohita, yes. Thanks for confirming, Lohita. Now, question is which one of the following is a top-down parsers? Recursive descent parser is a top-down parser, and these three, shift reduce, SLR, LR, are bottom-up parsers. These are called bottom-up parsers. It is also one of the PYQ in GATE. Okay. Look at the next question. Recursive descent parsing is an example of. Recursive descent parser is a top-down parser. Correct, no? Fine. Top-down parser generates. See, the questions are very simple. The top-down, Atreya, thanks for confirming. Top-down parser generates leftmost derivation. Bottom-up parsers uses rightmost derivation in reverse, but top-down parser generates leftmost derivation. What is a YAC? YAC is a parser generator tool. YAC stands for yet another compiler. This is a YAC. What is YAC? YAC is a parser generator tool which uses LA-LR parsing method. A given grammar is called ambiguous. When we can call a grammar is ambiguous? A given grammar is called ambiguous if two or more productions have the same non-terminal on the left hand side. No, it is not the case. A derivation tree has more than one associated sentences. One derivation tree will have one associated sentence, not more than one sentence. This is also wrong. There is a sentence with more than one derivation tree corresponding to it. Perfect, no? So means when I can call grammar is ambiguous for some sentence if we have more than one derivation. For some sentence if we have more than one derivation, we can call ambiguous grammar. Brackets are not present in the grammar. What is that? Okay, it is a silly question. So we can say answer is option C. Right, Lohita? Very good. Now look at. Which of the following productions eliminate left recursion in the productions given below? Which is eliminating left recursion in the productions given below? Which of the following productions eliminate left recursion in the productions given below? Any left recursion associated with S? No. But left recursion is there with A. And see, this is a straightforward our classroom question. It is given in ISRO 2013. So I'll be teaching from 2010 onwards, the same question. But it is given in 2013 in ISRO. It is our classroom practice question. Now what we have to do, it is a direct left recursion is there with A, and A deriving S, S is deriving A. So indirect left recursion is there with this one. So what we can do in place of that, we can write either A or B, so that indirect left recursion can be eliminated. Means we don't do anything with this first one, but second one we can eliminate it. A tends to AC, or in the place of S, if I use capital A small a, I'm going to get AAD. In the place of capital S, if I'm getting B, BD or epsilon possible. Now it is a direct left recursion and repetition is with C and AD. So what we can do, we can replace that first one with either BD, and repetition I can call A dash, or second alternative is epsilon. So epsilon A dash means A dash. And what is possible with A dash? Repetition of C's happens, C A dash or AD A dash, or for terminating epsilon. These are the grammar productions 1, 2, 3. Now look at what is there in the option A, S tends to capital A small a or B, perfect. And this is not changed in any of the options, and only the second one, A tends to BD A dash, but and only A dash also possible. So this option A is wrong because one more A dash is not there. A tends to A dash and BD A dash, perfect. And A dash should be C A dash, AD A dash and epsilon. Okay, option B is a perfect answer for this. So B is the correct answer and C and D are the incorrect options. Why this is incorrect option? This is wrong, and here also it is wrong. C and D are incorrect options, B is the correct answer. Okay, that is about left recursion elimination. I hope you know it. What I have done, converted indirect left recursion to direct and eliminated. That's it. Okay. Now this is a question: which grammar rule violate the requirements of the operator grammar? What is an operator grammar? no two non-terminals are adjacent, and it should be null-free grammar. This is violating, here this is violating because two non-terminals are adjacent, 1 and 4 are violating. That is matching with option D. Okay. It is latest in 2023, means ISRO 2023 paper which happened in 2024 January, okay, but we call it as 2023 ISRO paper only. In the context of parsing techniques, LL of 1 refers to, what is LL of 1? LL of 1 says first L stands for left to right scanning of the input, second L stands for leftmost derivation, and the 1 indicates the look ahead symbols, means by looking one input terminals at a time it can take the parsing decision. Grammar that pass the input from left to right produces a rightmost derivation. Directly wrong it is, because LL of 1 is for top down parser. Top down parser uses leftmost derivation. So rightmost derivation wherever is given, it is wrong. And option B, grammar that pass the input from left to right produces leftmost derivation with one symbol allocate off. Okay, that sentence is not properly done, but okay, I will keep aside. Grammar that pass the input from left to right and backtrack at most once. Backtracking is there for brute force technique, not for predictive parser. Grammars that pass the input from right to left. Okay, is it from right to left? No, left to right actually. So parser should scan the input always from left to right, whether it may be top down parser or bottom up parser. Parser do left to right scanning, but never right to left. So D is wrong. So correct answer is B. But here sentence is not properly framed, but whatever is there I have copied as it is from the ISRO paper. But actually how could be the sentence? Grammar that pass the input from left to right produces a leftmost derivation with one symbol a look ahead of, means with one look ahead symbol. Best thing is with one look ahead symbol, with one look ahead symbol. Sentence is not properly framed, but that is only given, so I have copied as it is. This is ISRO 2023 question. And when it comes to the optimization, substitution of values for names. Wherever values for names is nothing but variables, okay, whose values are constants, okay, whose values are constants is done. Suppose a equal to 2 and it is a constant variable, int a, constant variable. Wherever a is there, that you have to replace with 2. This is called constant propagation, right? Constant propagation. Do you have a constant propagation? No, it is a constant folding. Actually, constant propagation is different, constant folding is different. Constant propagation means the variable whose value is constant, that is replaced. Here it is called constant propagation. That is what it is said, replacing names with value, okay. But constant folding means, suppose if it is 2 plus 3 is there, this is a constant expression, this is folded to make it 5. That is called constant folding. So constant folding is wrong, loop optimization wrong, strength reduction is replacing high strength with low strength. But what should be the technique? It is constant propagation. And so constant propagation technique is one of the local optimization techniques. So I can say local optimization is correct. But actually, unfortunately, in ISRO 2009, it is given constant folding is the answer. But we can't say like anything. But actually, the correct answer should be constant propagation, because constant propagation is going to replace the constant variables with their values, and constant propagation is one of the local optimization techniques. Because that is there, I choose that. Okay. This kind of confusion questions if comes, we can't do anything. Okay, we have to accept it. In compiler terminology, reduction in strength means replacing costly operator with cheaper one. That is an option D. That is a ISRO 2011 question. And consider the code segment, and this is also one of the previous gate question, direct from the previous gate. I think this is the same question asked in gate 2015. What they have given is, they have given some code snippet, and these are the options given, asked you to find false statement. The code contains loop invariant computation. This is a gate 2015 question, you can check it. The code contains loop invariant computation, means the code that not necessary to be present inside a loop is called loop invariant computation. Do you have any such code? Here you look at I modulus 2. I modulus 2 is there inside a J loop, but it is not required inside a J loop. Why? Because for each I, J repeating from 0 to n, for 0 to n times J repeating, I value is not changing. So for all 0 to n times, I modulus 2 is performing. But instead of performing I modulus 2 every time J is incrementing, perform I modulus 2 only for one time, and we can use that value for n times in the J loop. So this is a loop invariant computation. I can call I modulus 2 should not be present inside a J loop, it should be present inside a I loop, so that we can avoid n times that I modulus 2 computation. So the code contains loop invariant computation, correct, but question is about false. So because false, it is wrong. There is a scope of common sub expression elimination. Look at any common sub expression. Look at here 4 star j and here 4 star j. Both the values are same. Why? Because between these two statements, the value of j is not changed. Because between these two value of j not changed, what we can do is t2 equal to 4 star j. We can perform once and 2 times we can use it. Then I can call 4 star j is a common sub expression. There is a scope of it. This is scope is there. There is a correct statement because question is about false, wrong. And option C says there is a scope of strength reduction. Here it's very clear. 4 star j, we can write it as j left shift 2 times. As we know that every shift multiplies the number by 2. 2 times you shift it, it multiplies the number by 4. And we know that multiplication is costly, shift is cheaper. So there is a scope of strength reduction, yes, because question is about false, wrong. There is a scope of dead code elimination. Is there any code which is not required to be there inside a program? So every code has its own impact because everything it is performing it, and we can't find any dead code in it. So because there is no scope of dead code elimination, but it is mentioned there is a scope of dead code because every code is important. Like incrementing I loop is important, J loop is important, inside a loop performing these operations are also important, right? So nothing we found which is not required to be present in a program, because the code that does not have any impact is called dead code, but every code has impact. So that this is an incorrect statement. Question is about false statement. So option D is the false statement for this. Okay. And with this, we have completed all 38 questions, okay, in a short time. So that's about all PYQs from ISRO from 2007 to 2023 ISRO. So in your success journey, we are extending our helping hand to make your preparation easy, to make you solve. We will making solve all PYQ questions, and that will be definitely helpful for you. I hope you are enjoying this session, and follow this kind of our PYQ series every day that is coming. If you have not attended any lectures, because it is available in the YouTube, you can watch that previously. Previously I have taken DBMS PYQ series also. In the process of extending our help for your success journey for mission 2025 ISRO. So what ACE is offering? ACE is offering pre-recorded lectures, and these pre-recorded lectures are available in the ACE online app. You can download that ACE online app, which is free to try for first 7 days. So some recorded lectures are available for you to watch. You can watch it, and if you are okay, we can go with the subscription. And moreover, especially for ISRO, and we have a program called Quick Revision course. This is also pre-recorded lectures. We have something around 250 plus hours of lectures, and those are very clear and crisp in a short duration of time. All the courses are going to be completed. And we have exclusively GATE plus ISRO PYQ pre-recorded lectures, and that could be helpful for you, because anyhow ISRO PYQs all we are covering in the YouTube sessions, but GATE PYQs will be helpful for you. And even we have Hindi lectures. अगर आपको पढ़ाई करना है तो हमारे पास हिंदी का lectures भी available है. हिंदी में पढ़ना है तो पढ़ लीजिए. So आपका पढ़ाई बहुत आसानी हो जाएगा. And we have ISRO PYQ booklet, which is available in the acepublications.com, Amazon and Flipkart. So you can purchase ISRO PYQ booklet. That will be helpful for you for your preparation. And I would like to end up my session to just saying one thing. जीत और हार तो परिणाम है, कोशिश करना हमारा काम है, कोशिश करते ही रहिए. Do your best and never quit. One day or other day you are going to become a kingmaker to get a success. Wishing you all the best. Good luck. Jai Hind.